What's up, guys? This is my first ever YouTube tutorial, and it is about how to build a dubbing pipeline from scratch. Quick intro on me. I am from Civ. We build a ton of different APIs and infrastructure for video AI. And today we're going to kind of talk about the basics of building a dubbing pipeline and how you actually build something that works well. Obviously, AI dubbing has kind of gone mainstream, right? You see YouTube doing it, you see Mr. Beast doing it, you see it in these kinds of poker tournaments. It's sort of all over the place. The reason it's gone mainstream is because every single component that's required for it has gotten relatively good, from the text to speech to the lip syncing to the transcription, translation. All these components have just improved quite a bit. And today we're going to try to go from the most basic version of a pipeline, combining these components, to something that works pretty well at the end. So to start, let's go with the simplest implementation. And bear in mind, this is a presentation I've given in a couple places. And so the examples I might use are people from those places. So yeah, but quick start here, right? So the simplest implementation of this would be a world where you transcribe the audio, you go translate it, you go do a voice clone with a model based on that entire audio. And then, the audio duration might not match up. So you smush it or you make it longer, to match the audio duration. And then, you merge that with the original video and you're done, right? And let's kind of watch this example, based on that. So this is the original.
Hi, we're Mux. We're a video analytics tool that you can use to improve your video delivery over the web. It's quick and easy to implement too, with just a few lines of code.
That's the original, right? And let's watch the dub version.
Hola, somos Mux, análisis de video, que puede usar para mejorar su entrega de video a través de la web. Es rápido y fácil de implementar también con solo unas pocas líneas de código.
So you'll notice that, it was all right. It wasn't bad. The voice sounded different and the code was super simple. You can see it here. It was all these just open source models where I used Whisper, I used seamless text to text to translate, and I used a model called XTTS, for the text to speech. And the rest of it is just some FFmpeg logic to match the audio duration and replace it. Not bad if you look at that one example, right? But let's go look at some others. So let's take that same video earlier. That was just a chopped up version of it. Let me play the entire video, right?
Hi, we're Mux. Section. Cover specific views.
So you'll notice this was a 43-second video. And now let's play the dub version.
Hola, somos Mux. Somos una herramienta de análisis de video que...
So you get the point, that speed up logic, it was too slow when I kind of slowed down the audio to match the original duration of the video. And then if I go look at another example here, I have this conference.
I'm here with Ron at the Pier 5 booth. Ron, why don't you tell us a little about yourself and what Pier 5 does?
Sure thing. So, I'm Ron Cantor from Pier 5. I'm responsible for sales and business development here.
And then let's play the dub version.
Estoy aquí con Ron en el stand de Pier 5.
So you'll basically notice that I just run into a bunch more problems. Here it's just like kind of the text to speech just like screwing up and just giving me this radio noise for a lot of the video. And above it's this kind of very slowed sounding speech. So let's kind of think about how we would, tackle that problem, right? How would we improve it? Well, with transcription and models like Whisper, one thing that's super common is that you get not just the, transcription back, but you get these segments with the timestamp. And so previously we were taking the entire audio file, we were translating it all in one shot, and then we were doing the text to speech all in one shot. But naturally these models aren't super reliable. So maybe we can do something where we do that same process, but we do it for each segment individually, right? And so this second implementation I have, it's the exact same as the one previously, except I am basically doing it on a per segment basis. And now let's kind of watch that same video I had played earlier, right? Again.
Estoy aquí con Ron en el puesto de Pier 5. Ron, ¿por qué no nos hablas un poco de ti, de lo que hace Pier 5?
Así que sí, soy Ron Cantor de Pier 5. Soy responsable de ventas y desarrollo de negocios aquí. Pier 5 es la CDN, sin servidor continuo y bajo demanda. Así que nuestra tecnología utiliza WebRTC.
So you'll notice there that, it's better, but it's nowhere near perfect. And it's totally noticeable that something's off. The text-to-speech model is bad. There's a couple other things that are wrong, right? So instead, let's now go try to tackle those problems. One thing that might not be so noticeable in this video is that there's background noise, in that video that, naturally it's not in the final video because I'm just doing text to speech. So there's a lot of models out there. Resemble Enhance is one, but there's a lot of different models out there that can remove background noise from audio. So if I have the original audio, right?
I'm here with Ron at the Pier 5 booth. Ron, why don't you tell us a little about your...
And then I have the denoise version.
I'm here with Ron at the Pier 5 booth. Ron, why don't you tell us a little about yourself and what...
So you'll notice that like little background noise is gone, in the denoise version, right? So now what I could do is take that denoised audio. I could subtract it from the original and place it back into my final audio. And so it feels a little bit more natural, and it might be hard to notice, but, let me play this here.
De lo que hace Pier 5.
Soy Ron Cantor de Pier 5.
So you'll notice that there's like some of this audience background noise in the back. It makes it feel a little bit more natural, right? But obviously the text to speech still sucks. And so let's go find some better text to speech. And, there's a lot of places you can search for, good text to speech models. This is on Hugging Face. There's an arena of like different text to speech models in the wild. A popular one today is obviously 11 Labs, but there's a lot of different competitors kind of coming out, both closed source and open source models that are starting to perform really well. And so you can kind of pick your text to speech model of choice. And then you have all these other edge cases you can go and solve. And maybe part 2, I'll go over all these edge cases. This could be an hour-long video if I went through this right now, where maybe I can break these problems down, right? Like, sometimes segments are really short. But if you want to do voice cloning, you need to make sure that your segments are long enough to clone the intonation and the actual timbre of the voice well enough, right? And then obviously languages where the audio lengths vary drastically, right? You notice that we were doing the speeding up and slowing down to kind of still match the timing of the video. But naturally, like languages vary in spoken length, right? So the text to speech you're doing will be of different lengths. So how do you manage that problem without making it sound unnatural? The next thing is like hallucinations in the transcription. Not every transcription model is reliable. Not every single model works well on every language. Not every model gives you good, precise timestamps for every word, right? So those are more problems. Obviously the quality of the translation is another problem where, newer models like GPT-4 are getting really, really good. But some of these open source models are just not good enough at less common languages. And then there's obviously like, splitting up segments in non-Latin languages and trying to match the intonation and the vocal tones perfectly. Those are just a few of the next problems we'd solve, but there's a ton more. And then if you go solve all those edge cases is when you finally get to a solution that sounds better, right? So that same example I had earlier, let's play this version.
Ron, ¿por qué no nos hablas un poco de ti y de lo que hace Pier 5?
Seguro. Soy Ron Cantor de Pier 5. Soy responsable de ventas y desarrollo de negocios aquí. Pier 5 es la CDN sin servidor, creada para vídeo en directo y vídeo.
So it's much, much better than before. Another one, this one is a video that's originally in...
И просто вы не знаете, у кого какие проблемы будут. Моя мысль такая, что в целом я сейчас...
So that's the original. Let's listen to it in English.
In fact, the guys are not 100% healthy, and you just don't know who has what problems they rarely talk about. My thought is that, in general, I now understand that, and looking at my peers here, I am almost 35 years now, 34, but I'm almost 35, and I realize that my overall health is pretty good compared to...
So you see, it's just much, much better now. It's matching the time, it's matching the tones and intonations, right? Another example here, and I'll make sure to link this presentation in the description, so you can see the code samples and all of that. But you see how much better you can get when you engineer all of these edge cases really well. And so, yeah, that's a little quick intro on what it takes to kind of build a good dubbing pipeline from scratch. One thing I do want to just say at the end is like, we do have a version of this that's on Civ that solves a lot of these edge cases that you can try. And so you can go to our website, check it out. We solve a lot of these problems for you. And you can do even cooler things. You can stylize the languages, pick different voices and all of that. So yeah, that is basically it for today. Thanks for tuning in. Drop, I don't know, 100 likes and maybe we'll do part 2. So yeah, thank you.